Accidents involving fuel tanker trucks and other vehicles transporting flammable liquids present major challenges to first responders. One of the most critical is the danger of electrostatic discharge, which can instantly turn a potentially hazardous situation into a life-threatening disaster. To help mitigate this risk, standards such as NFPA 472 mandate that hazmat personnel set up and bond the tankers to a temporary grounding system before offloading flammable liquids from the damaged tanker to the receiving vehicle. The purpose of this grounding system is to create an equipotential plane between the two vehicles and all equipment used to pump the liquid from one to the other. To help make this process as easy and safe as possible, AEMC has introduced the Static Ground and Test Kit. This portable system contains all the necessary equipment for creating and testing a temporary grounding system for the transfer of hazardous materials, including a test instrument and accessories to ensure the system is fully functional and in compliance with relevant standards. The kit enables responders to ensure the safe transfer of hazardous liquids by minimizing the risk of spark ignition due to electrostatic discharge. This video explains how to use the Static Ground and Test Kit. We begin by describing the kit's components. We then demonstrate how to use the kit to set up a temporary grounding system, and then test this system to ensure it provides the grounding performance required for your location. Finally, we explain how to connect the grounding system to the damaged and receiving tankers and other equipment. The kit is packaged in a hard shell case designed for rugged environments and consists of two parts. The first includes rods for creating a grounding system. These are steel rods with copper cladding to prevent corrosion and rust. The grounding system can consist of a single rod or multiple connected rods. Typically, you will create one grounding field for the damaged tanker and a second for the receiving tanker. You can also create a separate grounding field for the transfer pump in cases where it is a portable standalone device not mounted to the fire truck. An insertion extraction tool for installing and extracting the rods. Auxiliary electrodes for testing the grounding system. These electrodes are used for injecting test current and measuring potential. Couplings for connecting rods in situations where the rods must be hammered to a greater depth to achieve the required resistance reading. The second part of the kit provides the AEMC Ground Resistance Tester Model 3640, a simple-to-use ground tester that can perform a follow potential test with a single push of a button. You will use this instrument to verify that the grounding system meets local requirements, as explained later in this video. Color-coded leads for connecting the auxiliary electrodes to the Model 3640. Jumpers for connecting the tankers to their grounding systems and to each other. These connections create the required equipotential plane. The jumpers consist of bare stainless steel wire to ensure they have no hidden breaks. Additional stainless steel jumpers for connecting rods together in locations where multiple rods are necessary to create a satisfactory grounding system. And an easy-to-follow instruction sheet. Our first task is to select a location for the damaged tanker's grounding field. Ideally, this is outside the hot zone that may exist around the tanker. This is the area in which flammable gases may be present, for example, evaporated fuel that has leaked onto the ground. You should first determine the extent of the hot zone, with a gas detector designed to detect these gases and display the lower explosive limit, or LEL percentage. If at all practical, install the grounding system well outside any potential hot zone. Also, if possible, choose a location uphill and upwind from the hot zone. After a suitable site has been selected, you can install a grounding system. If soil conditions allow, you can insert the rod by hand. In hard or compacted soil, use the insertion extraction tool that comes with the kit to install the rod. Screw the threaded end of the rod into the tool and then install the rod with a hammering motion to a depth of 24 to 36 inches. Then unscrew the rod from the tool. With the first rod installed, we will now measure its effective resistance by performing a follow potential test with the Model 3640. This involves injecting a low current into the ground at a distance from the grounding rod, and then measuring potential at a point between the grounding rod and auxiliary injector electrode. For more information about performing follow potential tests, as well as ground resistance testing in general, see the workbook Understanding Ground Resistance Testing, available free on the AEMC website. The Model 3640 runs on AA batteries. We recommend keeping an unused set of batteries in the responding vehicle and installing them on site. This ensures the instrument always has fresh batteries to provide power. It is also good practice to remove the batteries after returning to the station, since the instrument generally will not be used on a frequent basis. In the follow potential test, the injector electrode should be inserted approximately 80 to 100 feet from the grounding rod, and the potential electrode placed approximately 60 to 62% of the distance from the injector electrode to grounding rod. Both auxiliary electrodes should be placed outside the hot zone. Connect the red lead to the injector electrode. Insert the spindle tool that comes with the kit into the spool to allow it to spin freely, and bring the spool back to the instrument. When a sufficient length of lead has been played out, push the lever on the spool to release the tool. Insert the red jumper into the spool's banana jack. In the other end of the jumper, insert a provided spade clip, and attach the clip to the red terminal on the instrument, labeled Z. When you do this, ensure the metal jumper strap attached to the red terminal is not connected to the blue terminal. This jumper is not used when performing a follow potential test. Similarly, use the blue lead to attach the potential electrode to the instrument's blue Y terminal. Finally, use the green lead to attach the instrument's green X terminal to the grounding rod. To take a measurement, simply press the button and wait a few seconds for the reading on the display to stabilize. In some jurisdictions, a resistance under 1,000 ohms is acceptable for a temporary grounding system in this application. Other jurisdictions require the resistance to be under 25 ohms. Be sure you know the requirements of your location before connecting any cables and pumping equipment to the damaged tanker. When performing a test, note the 3 fault indicators on the Model 3640's front panel. If any of these lights are lit, check all connections between the instrument, auxiliary electrodes, and grounding rod. If the measurement does not meet the standard mandated by your area, there are a number of measures you can take. For example, to improve conductivity, you can moisten the soil around the temporary grounding system by pouring water on it. Another option is to add 1 or more additional ground rods. Insert the second ground rod a minimum of 1 rod length away from the first, and bond it to the original via the jumper cable provided with the kit. Similarly, you can add a third rod placed a rod's length away from both the first and second rods. You can also use the provided connectors to attach a second rod to the original, and then use the insertion extraction tool to hammer them deeper into the ground. And if a guardrail is available, use the jumpers to attach it to the grounding field. In some locations, the guardrail by itself can provide a satisfactory grounding field. In every case, perform a follow potential test afterward to ensure the grounding field meets your local requirements. When the readings are acceptable, and if time permits, we recommend taking a few minutes to perform 2 additional measurements. These involve moving the potential auxiliary electrode to 52% and 72% of the distance between the injector electrode and grounding system, and taking a measurement at each location. If the 3 measurements are within 3% of each other, the injector electrode is sufficiently distant from the grounding system to provide a reliable and accurate measurement. After you have set up a grounding field for the damaged tanker, use the same procedure to create a separate grounding field for the receiving tanker. Although it's possible to use a single grounding field for both the damaged and receiving tankers, we recommend separate fields for each to ensure redundancy. For example, in case a cable is accidentally disconnected during liquid transfer. And as an extra safety measure, you can also create a separate grounding field for the transfer pump equipment. The final step is to connect the grounding fields to the tankers. Start with the damaged tanker. Connect the grounding jumper to a point on the tanker directly welded to the vehicle frame. The reason we connect the damaged tanker first is to ensure that any electrostatic spark created as a result of the connection occurs outside the hot zone. Connect the other end of the grounding jumper to the grounding field. Next, connect the receiving tanker to its grounding field. Then connect the damaged tanker to the receiving tanker. Again, connect to the damaged tanker first to avoid electrostatic spark within the hot zone. Finally, connect the transfer pump to its grounding field if you have created one for it, and then connect the damaged tanker to the pump. You have now created an equipotential plane that will minimize the risk of static spark during flammable liquid transfer. Note that you can use this plane to ground any buckets used to capture leaks from the damaged tanker. To do this, place the bucket outside the hot zone, connect a grounding jumper to the tanker, and connect the other end to the bucket. You can now bring the bucket into the hot zone to catch any leaking fluid. When all fluid has been offloaded, remove all connecting wires from the ground rods, tankers, and other equipment. As you do so, be aware that volatile vapors may still be present on or around the empty damaged tanker. Then extract the rods using the insertion extraction tool provided with the kit. Let's take a moment to review the main tasks required to create a temporary grounding system that provides an equipotential plane for the offloading of hazardous liquids. Determine an appropriate location for the grounding systems outside the hot zone that may surround the damaged tanker. Install the ground fields using the grounding rod supplied with the kit. Create separate fields for the two tankers and ideally the pumping equipment. Perform a follow potential test to ensure each field provides satisfactory grounding. If not, install additional rods to lower the resistance of the field. Connect each grounding field to its tanker and the pumping equipment. After offloading, disconnect the grounding fields, dismantle them, and return all components to the kit. This concludes our demonstration of the static ground and test kit. For more information about this kit or the Model 3640, visit the AEMC website. And be sure to check our YouTube channel for instructional videos about other topics in electronics, including the many products offered by AEMC.